Today's lesson is on factors. First, let's do some review from polynomials. Let's look at some definitions. A polynomial is a monomial or sum of monomials. Monomial is a number, a variable, or product of a number and one or more variables with whole number exponents. Binomial, a polynomial with two terms. Trinomial, a polynomial with three terms. First thing we need to look at is the degree. Degree of a polynomial is the highest exponent value of one term of a polynomial. Let's find the degree of these three polynomials. Highest exponent, number 1, 1. So our degree is 1. Number 2, highest exponent is 2. So 2 is the degree. Next problem, number 3, highest exponent is 4. So our degree is 4. Second thing let's look at is, let's write it in standard form. Standard form is when we write the polynomial with the terms in decreasing order. Decreasing means highest exponent to lowest exponent. My highest exponent in the first problem is 3. 3x cubed is my first one. Keep the sign in front of the term with the actual term. Next, we got 3x squared. Sign in front of the 3x squared is positive, so we're going to put plus. Then we got plus x. Subtract 12. Let's get the next one. Highest exponent, 4. 3x to the 4th power. Remember there's a negative in front, so negative in front of the 3. X squared. Plus in front of the x squared. Plus 4. Now let's look at the third example. Highest exponent, 2. 2x squared. Minus 4x. Plus 5. Third thing, the leading coefficient of a polynomial is the coefficient of the variable with the largest exponent. Let's look at the last section, part 2, and let's do the largest leading coefficient. Leading coefficient of the first one, if we put it in descending order, would just be the coefficient for the first term, which is 3. Leading coefficient for the second one, negative 3. And the third one, negative 2. Or positive 2. Alright, part 4, let's look at the constant term of a polynomial. It's the term without the variable. So let's go back to part 2. My constant term in the first problem is negative 12. Constant term in the second problem, positive 4. Third problem, positive 5. Now let's multiply polynomials. We're going to start by multiplying a monomial times a monomial. Here we have x cubed is x, xx, x to the 4th, the xx, xx. How many x's do we have? 7. So we have x to the 7th power. Let's look at the next one. A cubed. First thing we need to do is, since we got square, we need to write ab to the 5th power 2 times. Now a cubed is a times a times a, b squared, bb. And we got a 5b's another A, and then 5 B's. So total, how many A's do we have? 1, 2, 3, 4, 5. So A to the 5th. B, we have how many B's? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 B's. So we have, our answer is A to the 5th, B to the 12th. Now let's look at monomial times a polynomial. We're going to take negative 5x and we're going to distribute it to all three terms. So we're going to write negative 5x 3 different times. We're going to write x squared in the first parenthesis for the first term, 2x in the second parenthesis because it's the second term, 3 in the third parenthesis because it's the third term. We're going to have our minus in the middle for the first minus and the plus. Now we're going to take and multiply negative 5x times x squared. We got negative 5x cubed minus minus. Take this to a plus. 5x times 2x is 10x. Plus minus becomes a minus. 5x times 3 is 15x. We have to be, oops, we messed up. 5x times 2x is 10x squared. Now we need to look to see if we have any like terms. We do not in this problem. Move to the problem number 2. We have 4x. We're going to take that and we're going to distribute it 3 times. So we write negative 4x squared 3 times. 2x squared in the first parenthesis for the first term, 5x in the second, 9 in the third. We bring our plus down, and our plus down. Now we can have 4x squared times 2x squared is 8x to the 4th. 20x cubed plus 36x squared. Look to see if you have any like terms, and we don't here. We'll finish this problem. Remember, if we have a calculator, we need to check by putting the problem in Y1 and our answer in Y2 and go to our table to see if they match. Now let's do binomial times binomial. We have to multiply both terms here by both terms here. So let's rewrite what we see here. I see 6x times 3x plus 4. Let's move this over and rewrite what I have here. Plus 4. 3x plus 4. Now let's distribute. We have 6x twice. 3x 4 plus 5. 3x plus 4. 18x squared plus 4x plus 15x plus 20. We have like terms here. Plus 24 and plus 15 combined to be 39x off 39x. Now let's remember to check our answer. Problem in Y1, answer in Y2, and look at our table. Go over to the same problem. It's covered up. Right. Covered up. Right. Cubed plus x squared, 4x squared, plus 4x. Combine our like terms, plus x squared plus 4x squared. Get x cubed, 5x squared, plus 4x. Now we need to check our answer from 1 and 1 to the calculator. Now we're going to do a binomial times a trinomial. Again, okay, let's cover it up, rewrite what we have. Cover it up. Rewrite 3x 3 times because we have 3 terms this time. 2x squared minus 2x plus 1. Up to 2 3 times. X squared subtract 2x plus 6x cubed minus 6x squared plus 3x, 4x squared, plus and a minus is a minus, 4x plus 2. Now we need to combine like terms. Remember to write in descending order. I have minus 6x squared plus 4x squared. That gives me negative 2x squared. Positive 3x minus 4x gives me negative 1x. And then we bring down our constant term. No more like terms, so we need to check our answer. Problem in y1, answer in y2. You try number 2 on your own. Let's look at these multiplying special polynomials. Cover it up. Right. Cover it up. Rewrite. Have x squared minus 4x plus 4x minus 16. Combine like terms, I get x squared minus 16. Minus 4x plus 4x becomes 0. Try number 2 on your own. See if you can come up with the pattern. Here, when we do a multiplying special polynomial, the square means we need to write it twice. Now it looks like the problems that we've been doing. you can work them out and see if there's a pattern. Try this word problem on your own and see if you can answer these problems for the closure.